Now, okay, no?
Yes, madam.
Okay, let's see how to calculate the residuals first. This is the same data set that we have been using last week to calculate the ANOVA table. So we know in this case, we calculated the slope and the intercept. That is, the beta naught was 14.33 and beta 1 was minus 0.09. So in order to calculate the residuals, first we have to calculate the y hat value. So let's calculate the y hat values. How do we calculate the y hat values? We have to substitute the original x values for the estimated equation or for the estimated model to calculate the y hat value. So that is y equal beta naught value is this 14.33 plus beta 1 value is minus 0.09 into original x value. For each observation, you have to take the original x value. So in this case, for each and every observation, you have to use the same slope and same intercept, because we are just substituting the x values for the each and every observation to calculate the y hat values. So here we can calculate the y hat values, right? And then now we can calculate the residuals. That is, we have to just take the difference between y and y hat values. That is the difference between the original y and the estimated value. So in the, as for the first case, the first observation is 10.98. So minus the estimated value is 11.16. So when you get the difference between these two, you get the residual or the error. So now we have calculated the error values. So last week, using the ANOVA table, we have calculated the sum of squares and the mean square values. So you can see, if you look at the ANOVA table, our residual, if you look at the residual row, you can see the mean square. Error mean square is equal to 0.68. Right? So what you have to do is, now first, in order to calculate the Cook's statistic, we have to calculate the standardized residuals. Now in this column you have residuals, so we have to calculate the standardized residuals. How do we calculate the standardized residuals? After calculating the residuals, you have to divide each and every residual using the square root of the error mean square value. So in this case, error mean square is 0.68. You can see, using, if you look at the ANOVA table, if you look at the error row, the residual row, with respective to mean square value, you have 0.68. So you can use that value as for the error mean square, but here we have to take the square root of the error mean square. We'll just calculate the square root value. So if you just check the square root value of the error mean square, 0.6811. So that is 0.825. So we are going to use this value to substitute to this equation to obtain the standardized residuals. So in this case, we'll check the standardized residuals. So how to calculate the standardized residuals? We take the residual. Now first residual is minus 0.1804, and then we divide it by the square root of the error mean square. That is, we have obtained the square root of error mean square is 0.825288. So for each and every observation, you have to do the same thing to obtain the standardized residuals. So we have the standardized residuals now. And now we can obtain the leverages for each and every observation. So you can see that is the HI values. So the HI values we can obtain using this given equation. That is, we have to take xi minus x bar squared divided by xi minus x bar squared summation, and then we have to add 1 over n value for each and every observation. So here we have, if you look at the data set, we have 10 observations. So in this case, our n value is 10. So if you look at the equation, let's substitute to find the leverage values. So that is, you have 1 over 10, that is n value, plus then you have to take xi minus x bar squared. So we have calculated x minus x bar squared value. So we have to just substitute this. You have to divide by xi minus x bar squared summation. So xi minus x bar squared column is this, summation is 3007.344. So that also we have calculated. So for every observation, we have to do the same thing. So let's calculate the HI value. So we have the HI values. So what we have to just substitute to this equation and calculate the HI values. Now we know the HI value. These are the HI values. That is the leverages for each and every observation. Now we can calculate the Cook statistics. So I'll denote it using B, the Cook statistic. So that is, we have to use this equation. So you have to take HI value, divide it by 1 minus HI into RI squared over P. So RI means the standardized residual value. So this column, this is the RI column. Now we have to just substitute. We have calculated everything. So let's substitute now. If you look at the first observation, the first HI value is 0.25. You have to divide this 1 by 1 minus HI again. I'll put another bracket. And then you have to multiply this value by RI squared, that is standardized residuals. So you take RI squared value. And then you have to divide this by P. So in this case, P is the number of parameters. So in our case, P is equal to 2 because we have only one independent variable. So in our model, we have only 2 parameters, beta naught and beta bar. So P is equal to 2. So here we get the Cook statistic. So likewise, for each and every observation, we have to calculate the Cook statistic. And now we have Cook statistic for each and observation. So why we calculated this Cook statistic? Our objective is to find the outliers in our data set, the extreme points. So after calculating the Cook statistic, it's not a rule, but in most of the cases, we are using 4 over n minus p. This one as the cutoff point, right? But in some books, you will have different cutoff points. But in most of the cases, we are using the cutoff value as 4 over n minus p. So if I just calculated this value for our data set, 4 divided by n is equal to 10. And we have 2 parameters, 10 minus 2, that is 0.5. So what you have to do is, you have to check after calculating the Cook statistic, if at least you have to check the Cook statistics. If the Cook statistics is exceeding the cutoff point, you can identify that observation as an outlier. So if you look at our data set, now these are the values that we have obtained for Cook statistic, but you can see none of them exceed 0.5. All are less than 0.5. So in our case, we have no outliers in this data set. But Maybe in your exam for the data set I give you, if I ask you to identify outliers, you can just use this calculation and check what are the points which are exceeding the cutoff value, and then take them and identify them as outliers. So in this case, all are less than 0.5. So this is a good data set. We have no outliers. So our model is also a good fit, because we have not fitted our model using outliers. So likewise, we can identify the outliers using Cook's statistic. You understand that? Do you have any questions regarding the calculation? Okay, so if you have no questions with that, now we can move into multiple linear regression. So far what we have discussed is, in your data set you have only one y variable and only one x variable, and we wanted to forecast, or we wanted to predict the values for y using our x variable. So we fitted a model and we had only two parameters, and we know after fitting the model how to obtain the residual plot to check whether the residuals are having the constant variance, and how to obtain the normality plot. Likewise, we know what to check in order to check the accuracy of the fitted model. Now, in most of the cases, now when we are doing the analysis in practical situations, when you are given with the data set, we are working with the software, so you don't have to create all these plots manually. You have to just feed your data set and just get the plots. So what is important is you should know what plot to use in a given situation and how to interpret your values. That is the important thing, right? So on Friday session, I'm going to do the analysis using our software. So I'll be explaining you how to do the analysis. So you can do the analysis at the same time with me when I show you the steps, right? So we'll discuss how to obtain all these plots using R on Friday. With that, now when it comes to this multiple regression, now the difference between simple linear regression and multiple linear regression is, in this case, we have more than two predictors. That is, we have more than more than two x variables to fit our model, right? So that is, our response variable is depending on so many other factors. For an example, if you want to predict a model, if you want to, let's say you want to develop a model to predict the GPA of the students at the end of the second year. So in that case, let's say the GPA is depending on the time that the student is studying, and the GPA, let's say, depending on the traveling distance. Likewise, you are going to identify so many factors. So in that case, when you are going to predict your GPA, you have to consider all those factors. So in that case, you have more than one x variable. So you can't apply the simple linear regression. You have to go to a multiple linear regression, since you have so many x variables. So in this case, what is important is, when it comes to the multiple linear regression, even though when we have so many variables, when it comes to the reality, when you're working with the data set, what we always try is, we are trying to minimize the number of x variables. That is, we are going to find out the best fit for our data set. We are going to find the best model with minimum number of x variables. So in that case, we have to make sure what x variable that we have to add and what x variable that we have to drop from the model. අපි multiple linear regression model එකක් කරනකොට අපිට x variables ල ගොඩාක් ඉන්නවා. හැබැයි අපි හැමෝම අපේ මොඩල් එකට දාගත්තොත් එහෙම අපේ මොඩල් එකේ accuracy එක evaluate කරන්න අපිට අමාරුයි. එතකොට අපි හැමතිස්සෙම හදන්නේ අපිට ඕනේ x ලා අඩු ප්‍රමාණකින් හොඳම මොඩල් එකක් හොයාගන්න. එහෙනම් අපි දැනගන්න ඕනේ මොන x වද අපේ මොඩල් එකට අපි දාගන්නේ. මොන x වද අපේ මොඩල් එකෙන් අයින් කරන්නේ. So that is something really important when it comes to multiple linear regression. Right? So in this case, if you can remember when we were doing the simple linear regression in order to obtain the parameters, we use the matrix form. So the same thing that we can apply when it comes to the multiple linear regression, because using the matrix form to obtain the parameters, it's much more easier than just simplifying the multiple linear regression equation and obtaining the values for the parameters. So in that case, what you have to do is, now if you look at the model equation, in general, when you write the model equation for multiple linear regression, we believe that we have k number of independent variables, right? So that is, you have starting from x1, x2, x3 up to xk. So in that case, if you write the model, you have yi is equal to beta naught, that is the intercept, and beta 1 x1i. x1i means the ith observation of the first variable, plus beta 2 times x2i, that is ith observation of the second variable. Likewise, beta k times xki plus epsilon I, that is the error. So you can see you have this is the general format of the model. So starting from beta naught, beta 1, beta 2 up to beta k, you have k plus 1 parameters in the multiple linear regression model. Right? You have k plus 1 parameters. Now let's see how to put this into the matrix form. Now in this case, let's say you have n number of observations in your model. So if you have n number of observations in your model, what you have to do is, you have to first take your response variable, that is the matrix y, and then we have to put all the y, the response variable, the values of the response variable as a column vector or as one column, and that is your y matrix. Response variables you have to put into one column as a matrix, as a column vector, and that is your y variable. And then when it comes to the parameters, so I told you, you have k plus 1. Starting from beta 1 to beta k, there you have k number of parameters, and you have beta naught also. So that is, you have k plus 1 number of parameters. So all the parameters you can put into this matrix, that is beta. So that is what we are going to actually obtain. Beta naught, beta 1, likewise you have up to beta k. So you have k plus 1 number of parameters. So this is again a column vector. You have k number of row, k plus 1 number of rows, k plus 1 into 1. And then you have n number of in this case, you have n number of error terms. For each and every observation, we can calculate the error. So if you have n observations, we have n number of errors. So all the errors you can put here. And then when it comes to the x variable, now if you look at the model, now if you look at the ith observation, right? Ith observation, you have beta naught plus beta 1. You have to substitute the respective value of the x1 variable and plus beta 2 times respective value of the x2 variable, likewise. So for each and every observation, you have the constant plus you have the respective parameter into the value of the given variable. So because of that, if you look at the x matrix, Now, since you have the constant, that is the intercept term, that we are going to replace with ones, right? So you have n observations. So you, as for the first column, you have to put n number of ones. Okay, and if you look at the second column, that is always in the second column is the value which is associated with the x1 variable. So that is the value of the first observation which is associated with x1 variable. So that we denote by x11. Then you have x12. Then you have x1k. Likewise, if you look at the first observation, for the first observation, you have all these values. So this is your, this is how you form your matrix. So in this case, you can see you have n number of rows. And if you look at the columns, for you have k number of x variables, and you have in the first column, you have only ones, that is k plus 1 number of columns you have. And in the observations, you have n number of observations, that is you have n number of rows. So this is how you just obtain the X matrix in the multiple linear regression. Now I will explain you using an example. So as it's same as the simple linear regression, we have certain assumptions in the multiple linear regression also. Actually, most of the assumptions are the same. That is, we believe when you take the error, that is error is it's having a, when you take the residuals, they are having a zero mean, and when you take the variance, they are having a constant variance, and these residuals are normally distributed with this zero mean and constant variance. And same as the simple linear regression, in order to obtain the parameters, you can use X transpose X inverse, X transpose Y to obtain the parameters. And then if you want to obtain the variance, we can use this. That is, we can just take the sigma squared value, and then we can multiply that X transpose into X inverse matrix to obtain the estimated value for the variance of each and every parameter, right? So that all these are same as the simple linear regression. So let's see how to do the calculations. So in this case, if you look at this example, it says a beer distributor is analyzing the delivery system for a product, and specifically the distributor is interested in predicting the amount of time required to serve a retail outlet. The industrial engineer who is in charge of study has suggested that the two most important factors influencing the delivery time are the number of cases of beer delivered and the maximum distance the delivery man must travel. The engineer has collected a sample of delivery time data and fitted the regression line, which is given in the following formula. So where X is the number of cases and X2 is the distance. So what you have to do is here, if you look at the data set, now in this case, we are going to predict, now it's regarding a beer distribution. So they want to predict the time which is taken to distribute this beer. So this time is, they think the time is depending on the number of beer that they are distributing and also the traveling distance. So that they have gathered data, what is the time and the number of cases that they have distributed and also the distance. So now in this case, they using this data set, they have fitted the regression model. So you can see your response variable is Y. There you have different observations for y, and then the y is depending on number of cases and the distance. So you have 2x variables. So it's more than 1. So you can't apply simple linear regression. You have to go to multiple linear regression. That's why we are using the multiple linear regression. And then in this case, if you look at the formula, see, now y is depending on beta naught plus x1 minus x bar, x1 bar plus beta 1 into x1 minus x1 bar plus beta 2 times x2 minus x2 bar. Now you can see it's not the same equation that we have been using. Here you have the centered form, right? For each and every, if you take the each and every variable, they have taken the difference with its own mean value. So when you are going to find out beta naught, beta 1 and beta 2, you have to consider this format. It's not just the general format. You have to use the centered format in order to obtain these values. All right, so let's see how to obtain beta naught, beta 1 and beta 2 value using our data set. So let's so I have the data set here. You have y, you have number of cases and the distance. So I'll take the number of cases as x1, and then I'll take the distance as my x2 variable, right? And now we are using this data set to obtain the parameters. But as we saw in the question, now the first variable x1 is not just x1. You have to take the x1 value and subtract its mean. So first of all, I'm going to find out the mean values of the variable x1 and the mean value of the variable x2. So I'm just using this function average in the Excel to find the mean. So I'm going to take the x1 data set and I'm going to take the x2 data set, and here we have the two mean values. The mean which is respective to x1 is 16.2 and mean which is respective to x2, that is 29.2, right? That is x1 by 16.2 and then x2 by is 29.2. So now we can calculate x1 minus the mean value of x1, that is x1 bar. Right, x1 minus x1 bar. So what you have to do there to calculate x1 minus x1 bar, so first you have to take the x1 value and subtract its mean, that is 16.2. So in this case, I'm going to subtract the mean value from each and every observation of x1. Same thing we can do to x2. We take x2 value, subtract the mean value of x2, that is mean x2. Okay. And then that is we take x2 observation, subtract mean is 29.2. 29.2 from each and every observation, and then we can consider x2 minus x bar values. So now we have two new values, x1 minus x bar and x2 minus x bar. So now when we are fitting the regression, we can use these two columns as our x variables, because here in the question, they want to take these two as their x variables, not just x1 and x2. So now when we are fitting the regression model, we can use these two as our x variables, right? Now, in order to obtain the parameters using the matrix form, now first we'll take the matrix of y. So in this case, if you look at the data set, we have 10 number of observations. So here are the y values. So what you have to do is you have to take all the y values and paste them as, or write them as one column. This is your matrix y. And then beta hat values, that those are the values that we are going to obtain. So now we want to find out the matrix X. Okay, so in matrix X, I told you we have n number of rows and k plus 1 number of columns. So in that case, n is 10. So that is, we have 10 number of rows. In this case, k means the number of x variables, the number of independent variables you have. So here we have 2 independent variables. Now our first independent variable is x1 minus x bar. Second independent variable is x2 minus x bar. So you have 2 independent variables. So in this case, our k is equal to 2. Right? So k plus 1 means then we have 3. K plus 1 is equal to 3. That is, we have to have 3 number of columns, n number of rows, that is 10 number of rows and 3 number of columns. So this would be our X matrix. So in X matrix, the first column, as you saw, we have to put 1. Since you have 10 observations, we have to put 10 ones. Okay. And how are we going to complete this one? How are we going to complete this one? So I'll give you a couple of minutes. So just take a paper and write down the matrix X and see whether you can write it down using the given data set in the matrix format. Okay, so if you look at the data set, now you can see, if you look at the first observation in this case, in our first observation, if you look at the 2 independent variables, the first value of the first independent variable is minus 6.2. So as in the first row of your X matrix, you have 1 here, that is to obtain the constant, that is the intercept beta naught. And the second, this is the coefficient of the second variable, that is minus 6.2. So here you have to enter minus 6.2. And here then you have to enter the coefficient of the second variable, that is 0.8. So here you have 0.8. And when you go to the second observation, that is you have here as the constant 1, and then the coefficient of the first variable minus 1.2 into minus 4.2. So likewise, you have to enter each and every observation to your matrix X. So I'll just copy the values here. So I'm going to just copy the values and obtain matrix X. So you have matrix X. Now, if you look at matrix Y, here we have n number of rows. That is, we have here 10 number of rows and only one column. That is, this is 10 into 1 matrix. And if you look at matrix X, again, you have 10 number of rows, but 3 columns. That is 10 into 3. And now if you look at our formula to obtain the estimates using the matrix form, first you have to take X transpose X and its inverse. So let's calculate X transpose now. So to calculate the transpose, this is the transpose of the matrix X. So in that case, we know when we are calculating the transpose, we have to take every column and write it as a row. So I'm going to just copy this first column, and here I'm going to paste it as the first row. Likewise, I'm going to take the second column and I'm going to take it as the second row. So in exam, you can use the scientific calculator to obtain these results. So I'm just using Excel because when you go to the industry in your in the next semester, it will be easy for you. The 4th year first semester, since you have the industrial training, in most of the companies, they are using Excel. So if you have a good knowledge in Excel, that will be easy for you to do all those work. Okay, now we have X transpose and we have matrix X as well. Now what you have to do is we have to calculate X transpose into X. So if you look at matrix X transpose, that is, here you have 3 columns, that is 3 into, and here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, so 3 rows and 10 columns. So here it's a 3 into 10 matrix. So what will happen when you multiply X transpose with X? That is, we are multiplying 3 into 10 matrix with 10 into 3. So our result should be 3 into 3 matrix. Now earlier also I have explained you how to obtain this multiplication in Excel. So here, since our result is a 3 into 3 matrix, now I'm going to select the area with 3 rows and 3 columns, and in the first cell I'm going to take matrix multiplication. This is the formula. So the transpose matrix is the first one. I'm going to select that, comma, the second one is the matrix X. I'm going to select matrix X and close the brackets and Control Shift Enter. Then we have this X transpose X matrix. But here we have to calculate X transpose X inverse. That is, we have to take the inverse of this. So this is a 3 into 3 matrix. We know when you calculate the inverse of a given matrix, you get the same dimensions. That is, again, we will get a 3 into 3 matrix. So I'm going to select the area with 3 rows and 3 columns, and then I'm going to select the function matrix inverse, and then I'm going to select the matrix which I want to calculate the inverse, close brackets, press Ctrl Shift Enter, then you'll get the inverse matrix. So I have, this is the X transpose X inverse matrix. And if you look at the formula, here we have X transpose Y as well. Now we have X transpose and we have matrix Y. Now we have to obtain X transpose Y matrix. So in X transpose, it is a 3 into 10 matrix. And if you take Y, that is 10 into 1 matrix. So if what will happen when you multiply 3 into 10 and 10 into 1 matrix, you have to obtain 3 into 1 metric, right? So in this case, I'm going to select 3 rows and 1 column to obtain this matrix. And then I'm going to do multiplication, matrix multiplication function. So X transpose is this, comma, matrix Y is this, close the brackets, Shift Control and Enter. Now we have matrix X transpose Y. This is X transpose Y matrix. And then we have X transpose X inverse matrix, this one. Now we have to take, if you look at the equation, we have to take X transpose X inverse multiplied by X transpose Y. You have to take the multiplication between these two. So this is a 3 into 3 matrix. This is a 3 into 1. So 3 into 3 multiplied by 3 into 1, we have to get 3 into 1 matrix as the result. So I'm going to select 3 into 1 area and then matrix multiplication. So X transpose is this and X transpose Y is this. And Shift Control Enter. Right. So these are the results that we obtain when we calculate the values using the matrix format. Now you can see here you have 3 values. Why you have 3 values? Here we have 2 parameters in the model, that is 2 independent variables. In this case, x1 minus xy is our first independent variable, x2 minus xy is the second independent variable. So with that, we are coming with 2 parameters and we have beta naught, the intercept. So altogether, we have to estimate 3 parameters. That's why we have come up with 3 values. So the first value, 29.3, that is the value associated with beta naught. And this is beta 1 hat. And this is beta 2 hat. Okay, so when you write the model, you can use these values to write the model. Now, in this case, when you write the model, you can write y is equal to beta naught value 29.3 here plus 0.59473 into, here you have to write x1 minus x1 bar. That is what you have in the original model. Right, you can write the model like this. You have y equal 29.3 plus 0.59473, that is beta 1 hat, into x1 minus x bar, plus you have beta then you can write beta 2 hat, that is 0.421397 into your next x variable is x2 minus x2 bar. Now in this case, this is how you have to write the model after evaluating the parameters. So in this case, if you just write y is equal 29.3 plus 0.59 times x1 into 0.42 times x2, that is wrong. Ogolo me parameters tika hoyala y equal 29.3 plus 0.59 into x1 plus 0.42 into x2 කියලා ලිව්වොත් ඔගොල්ලොන්ගේ model එක වැරදි, because in this case our x variable is this difference, y variable is this difference, so you have to indicate these two as your x variables and you have to write your model like this. So this is how you obtain the parameters using the matrix form. So actually we are going to use this matrix form to evaluate the parameters, since that is easy in multiple linear regression than using the equations. Okay, up to that point, do you have any questions? If you have any questions, you can raise them. Okay, if you have no questions, now I told you on Friday we are going to use our the software, that is our software, in order to do the calculations and take the outputs. So I will show you. So I want you, everyone of R is a free software. So I want every one of you to download that and come when you're coming for the Friday session. So when I show you the codes, you can just do it by yourself and see whether you're comfortable with the software, right? So because in the exam also, if like now as for the current decision, we are going to conduct a physical examination for you. In that case, you will be getting the outputs of this R software and I'll be asking questions. But in case if you get an online examination, it's possible that I can ask you to obtain your own outputs using our software and write down your answers. So in that case, you have to be very good with this software, how to work with this and how to do the analysis using R. So now I'll show you how to download R. You can just go to, you can just Google search as R free download, and then you will see this. That is download R 4.11 for Windows. So you can just click that. And then you will see download R 4.11 for Windows. So you can click on that. And then the setup will download within few seconds. So you can see now the setup is ready to install. So you can just open it and so there's nothing new to install this. So when you download this setup, you can just install it using the same way that you are installing the other softwares. You have to just open this setup, and then you will see that they will install our software, and I will show you what will happen after the installation. So you can select the language as English, and then so it will take some more minutes. We'll see. Okay, now I have installed R. So after installation, you will see that there will be a icon in your desktop. I'll show you.
Let's go.
Okay, I'm sorry. I had to take some time because anyway, now after installing, I can't share my desktop. So I just took a screenshot here. I hope you can see that. So in this case, you can see after installing, you have this blue color icon, which will be in your desktop. That is our software. So you using this shortcut, if you double click on this blue color icon, you can open our software, right? So I want you to download this R software and come when you are coming for the next session. Then it will be easy for you to do all these analysis. So if you have any trouble while doing the installation or anything, just let me know. I can help with that, because I don't think that you'll come across with any difficulty, because it's very easy to download and it's very easy to work with R. And R is the software that we are using in most statistical companies. So it will be easy for you to adapt to R when you're going to the industry. So that's why I wanted to show you how to actually download and install this one. If that if there is something unclear, please let me know. I will help you. And with that, I will stop today's session. Do you have any questions? Yeah, now some have asked, you have R 3.6.2 version. Yeah, that will be okay. So you can use any version, that's okay. Even if you have R 3.1.1, that is okay. Yes, and I will upload the lecture recordings today and all the lecture materials as well. Any other questions? All right, so then we'll stop today's session from this point. We'll meet again on Friday. Please install R and get ready and come. Okay, thank you so much and have a nice day.
Thank you, madam.
Thank you.